Today's lesson is Algebra 2 Lesson 7.5, Applied Properties of Logarithms. Take a look at the warm-up problems just to refresh your memory on some of the basic exponent properties. Some of those same concepts will apply when we are dealing with logarithms. As you look at question 1 and 2, you should remember that you are actually adding the exponents when you have the same base. Question 3 and 4, you're going to subtract your exponents when you're dividing the same base. Here's the key concepts for today. Just 3 properties dealing with logarithms. First property is the product property. If you're taking the log of a product, in this case log base b of m times n, you can rewrite this as log base b of m plus log base b of n. That multiplication, when it is expanded, becomes an addition problem. So in this case, when you're looking at log base 4 of 3 times 7, you're actually assessing log base 4 of 3 plus log base 4 of 7. Next property, the quotient property. This is when you're taking the log of a division problem, log base b of m divided by n. Following the same idea of the product property, multiplication turns to addition. In this case, division turns to subtraction. Take a look at this example. If you're taking log base 4 of 3 divided by 7, when it's expanded, you get log base 4 of 3 minus log base 4 of 7. Final property, the power property. If you're taking log base b of m to the nth power, that is expanded and that exponent becomes a coefficient. When you expand it, that log becomes n times log base b of m, as this example shows. When we apply these properties, we can expand logs. So in this case, we want to expand log base 6 of 5 times x cubed divided by y. Expanding this log is going to give us practice in each of the properties that we just learned. First thing you're going to do is to address the division. When you're expanding a log, you should think of it as you're doing this in the reverse order of PEMDAS. You don't see any addition or subtraction. So as you're doing a PEMDAS in reverse order, you do see division, and that's what we'll address first. That division becomes a subtraction problem. You will take log base 6 of the numerator minus log base 6 of the denominator. Next, keeping in mind reverse order of PEMDAS, as you go up in reverse order, multiplication would be next, and you do have a multiplication problem here. So now you will expand that multiplication problem to give 5 its own log and x cubed its own log. The final part of PEMDAS in reverse order would be to deal with this exponent. And an exponent, after being expanded, becomes a coefficient. So you can see at this example, all 3 of our properties were used to expand log base 6 of 5x cubed divided by y into log base 6 of 5 plus 3 times log base 6 of x minus log base 6 of y. Why don't you give one a try on your own? Take a minute and expand this one. Again, thinking of applying PEMDAS in the reverse order. Attack the division first. Then expand the multiplication, and finally take care of the exponent. Your written out solution should look like this. The division changed to subtraction, this multiplication changed to addition, and this exponent becomes the coefficient. One thing to keep in mind, because you might not always have a calculator that will calculate a log of any base. Currently, your buttons on your calculator, the keypad, will allow you to take a common log, that's when your base is 10, or the natural log when your base is e. But you cannot necessarily take log base 7 of A unless you can use the change of base formula. Let me show you some examples that will make this allow you to make even more sense. When you're taking the log base C of A, you can use the common log to calculate this log base C of A. You can take common log of A divided by common log of C. You also could use your natural log button if you chose. Take a look at each example. I want to evaluate log base 6 of 24, but I don't have a change of base function on my calculator. I could simply take common log of 24 divided by common log of 6, and that would give me 1.774. I could do the same calculation using the natural log. Again, I'm still trying to evaluate log base 6 of 24, but using my natural log button on my calculator, the LN button, I would take natural log 24 divided by natural log 6, and that still gives me 1.774. So even if you have a very basic scientific calculator, you can always calculate a log of any base using the change of base formula. Calculating logs is actually used in some real-life situations. In this case, this formula calculates the intensity, and it makes a comparison of the intensity of two earthquakes. So you see that logs do have real-life applications. Some people use them in their actual jobs.